So it's great to be here. I'll talk a little bit about myself and my background and why Google pays me to come here and talk to First Round Capital. And this is being recorded, right?
Yeah.
Okay, so maybe we'll turn the camera off after a while and then I can say some fun things. And I read the list. To be honest, I don't know much about First Round Capital. But I taught at Stanford and was very excited to do that. I know Don Knuth, and he greased the skids to get me in there. And but it was kind of frustrating because it was about, I forget, like 300 hours of work. And I only had about 45 students in the class. And so it was a lot of time to put in for a small number of people. And most of those people did not go into building websites, like less than half. There were people from all different departments and disciplines. And so then Google Ventures asked me to do a workshop for some of their portfolio companies, and was really good because most of the people, most of the engineers knew like a lot about the latest and greatest HTML5 and blah, 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 but maybe hadn't like really drank the web performance Kool-Aid yet or been exposed to a lot of it. And so I really like this opportunity to talk to people who are actively building websites and trying to get as many people to consume them and are really concerned about business effectiveness. We'll talk about that a little bit. And so I think it's I think the soil is very rich. And so I hope this goes well. I hope you guys enjoy it. And I was driving up here I don't know about you guys, I live in the South Bay, and the last few days have been kind of gray and rainy. And the sun came out about noon today, and so it's a beautiful day out there. So I was like, really, we're going to be inside for 2 hours? So we'll try to keep it more an hour and a half, and then we can do Q&A for as long as you want. And Kevin sent me a list of the companies coming, and it was hugely impressive, a lot of companies that I use. And if it's okay, maybe we'll just kind of start over here and just someone from each company shout out like what company you're from. What was that last one? Okay. How about Uber? Oh, yeah. I looked at your website. Anyone from Uber? Oh, cool. Did you say Uber? You guys are still stealth mode, I understand. Okay. And then I always make, the sad thing about doing so many of these talks is I've heard every joke that I've told, and so I think they're all pretty lame. Well, let's be honest, they are all pretty lame. But even for a terrible talk by a tech presenter, they're especially lame because I've heard them all the time. So one of the lame things I always say before I start is pay particular attention to the photos in the background of the slides, because that's where I've really put the most time in this talk. So this is the story of my life. See, I take slow things and make them fast. We might have to turn the lights out a little bit. Brian and I were at Yahoo for many years together. I was there for 8 years. I was the Chief Performance Yahoo, which is the best title I've ever had. I've been at Google for 5 years. All the work I do is open source. So the biggest thing I did was YSlow. That kind of started the web performance, interest and stuff. And I've done Cuzillion, SpriteMe. We'll actually look at those two today. Hammerhead, Browserscope was a big one that Lindsay Simon, now at Twist, I think, right around the corner, runs that project. And it's become, very, very successful. Jdrop is one of the, Jdrop and SpriteMe were two of the best things I ever built, and they never went anywhere. Or they stayed very small. HTTP Archive has gotten huge, and we probably won't talk about that too much today, but I encourage you to check it out, httparchive.org. And I wrote these 2 books that were pretty popular. I taught at Stanford, and I co-chair the Velocity Conference. We just announced New York, so we have Santa Clara in June, New York in October, London in November, and Beijing in December. And so the CFP is actually closed for June. If you think you have a really compelling talk after today, email me. We're just finishing the review process, so there's still some slots open, but certainly I'd encourage everyone to attend. It's gotten big. It started, this is our 5th or 6th year, and it's gone from 500 to 2,500 people. And it's all about operations, scalability, performance, all this stuff we'll talk about today. So I think today there are 3 main parts to what I'm going to talk about. So this first part is the Kool-Aid part, to just make sure we're all on the bus. And it'll be pretty fast, and to me it's kind of fun. I don't know if I get beat up for showing a VC from another firm. This is Fred Wilson from Union Square. How many people know Fred or read his blog? He blogs twice a day or something like that. It's amazing. And he's probably the #1 VC out of New York City. Individually, maybe not collectively. And this is a few years ago. He was at Future of Web Apps, and he talked about his 10 golden principles of successful web apps, and #1 on the list was speed. First and foremost, we believe that speed is more than a feature. Speed is the most important feature. And he went on to talk about how they have all of their portfolio companies monitored by Pingdom, and in their empirical data shows that certainly when the website's performance drops off, the business's performance drops off, and that's why he and his partners are so keen on performance. We had Alex Wegner speak at Keynote at Velocity last year from Union Square. And so this was, to me, was a crossing point. I think it was 3 velocities ago, I realized that we were getting really good penetration in the developer space, but they were running into roadblocks where a lot of times, depending on the company, decision-making does not rest in engineering. It rests in marketing or product management, and that engineers might be really keen on performance like they are on unit tests or QA, which maybe aren't the world's most exciting things to talk about or evangelize to someone in product or sales or marketing. And so about 3 or 4 years ago, I collected a bunch of case studies to come and present at Velocity about the impact of performance on the bottom line, and I'm going to run through some of those now. And so to me, this was a really crossing over point where, without any effort of my own, here's a guy in the business world getting up and talking about how critically important it is for websites to be fast. So that was very cool. And then a bunch of case studies came out of that. I managed on stage to get Bing and Google Search to stand up because they had both told me on the side that they had run basically the same experiment, which was to introduce intentional delays into the search results page. And even deeper than that, I won't go into it, at different points. What if it's on the server? What if it's after the nav head appears? What if it's after the first few results appear? Very intricate stuff. Bing took it up to 2 seconds and saw all their goodness metrics drop off, perhaps most importantly, revenue per user off 4%. Google only took it up to 400 milliseconds and saw, percentage-wise, a smaller change, 0.6%. But at Google scale, there's a direct correlation between searches per user and ad revenue. And so a drop-off of 0.6% at Google scale is a lot of money. And certainly, if they had taken this up higher, it's not a linear curve. It's geometric or exponential. So it would have been a lot bigger than that. And the scary thing about this was, after we had these buckets of users, and after the delay was removed, we kept people segmented in those buckets. And the people in this bucket, it took them, I think it was 6 weeks to get back to the level of search that they were doing before the experiment started. And so this reaction of users to your website, to how fast or slow it is, to what they expect, how they expect it to behave, is something that gets ingrained kind of subconsciously. And an important takeaway of that is, if you are running any kind of performance experiments, you might need to keep in mind that if you roll it out today, might not see the impact of that the day after that. You might have to let it run for a while. Similarly, if things degrade, you might not see a drop-off in business metrics the very next day after the drop-off, it might take a while before users really get turned off. But that was exciting to see, and it was exciting that they all agreed, and then Yahoo got into it and had a similar experiment, and for them, 400 milliseconds resulted in a 5 to 9% drop-off. Here's a different kind of business metrics. Mozilla cares about people downloading Firefox, right? They don't focus on the money so much. And so they made their IE landing page. This is if you're in IE and you want to download Firefox, you get redirected to the IE landing page. They made that page 2.2 seconds faster and saw a 15% lift in conversions. Yeah. This is a more recent one. This guy's going to speak at the next Velocity. Kyle Rush worked on Obama's most recent campaign and made their campaign page 60% faster, and it had a 14% lift in donation conversions. So that's exciting, unless you're Republican. This is a seminal study that was from the Velocity 3 years ago from Shopzilla, where they covered so much. They made their site about 4 seconds faster, from 7 seconds to 3 seconds, and they saw a conversion rate go up 7 to 12%. They deployed this across different countries and different types of product lines, and so there was some variation there. This was a very exciting one where they saw their search engine marketing, basically AdWords, unique user sessions more than double. Right? And this is because about 3 years ago, Google announced that when you participate in AdWords, you have this quality score. And one of the components of your quality score, is like, do you have, porn or, security stuff, but also how fast is your site? And we announced this publicly like 3 years ago. And so they made their site a lot faster. They didn't do anything else with bidding more money or anything like that. And if you have a low quality score, when in the search results page, even if you pay the same amount as someone else who has a fast site and doesn't have porn and has good security, you're going to be demoted because your site is lower. And so just by making it from 7 seconds to 3 seconds, they moved up the list and doubled the impact they're getting from their ad expenses. So that was huge. And this was the first study that touched on this new area about reducing operating costs. So all the case studies so far have had these increases in business metrics, and here's a decrease in operating costs. They could run the site on half as much hardware as they had needed before. And this makes total sense. How many people think this makes total sense? They improve the site and they need half as much hardware. Because you add an expires header. And now it used to be that every time the user loaded the page, they'd at least have to ping the server and see if that image was expired yet or not. And even if the server said, no, 304, not modified, you can still use it, that's still a hit on the server. And most pages have 50 to 100 images on them. And so all of a sudden, if you add an expires header, users don't have to keep pinging your server. So you're going to see the load on your server decrease by about 90%, right? Just by adding an expires header. And also the bandwidth out is going to drop. Well, we'll see that one next, I think. Yeah, so this was Bill Scott from Yahoo. Do you remember Bill? Worked on YUI with Doug Crockford on Ajax stuff. And then he went to Meebo and Netflix twice. And now he's at PayPal with Doug. But when he was at Netflix, they had one of those experiences like in 1998 where they had compressed JavaScript and someone with Windows 3.1 that hadn't downloaded Service Pack 2 had a bug where if you compress JavaScript, it would, the page wouldn't load or something like that. And they decided never to compress anything ever again. And so he turned on compression, and the NOC called him up and said the site's down. And he said, why do you think that? They said, well, our traffic leaving the data center just dropped in half. The only thing we can be serving is the error page. And he said, nope, we just turned on compression and dropped outbound traffic from the data center in half. How many people here know how much you pay for traffic in your data center? Anyone? So cut it in half, like at least 5, if not 6 figures a month, yeah? So one simple change, turn on compression, and there's very few people who have IE6 without Service Pack 2. So the chances of a bug are very low. Here's Ishmael from Edmunds.com. He took over a new site, and wanted to do a small change very quickly to convince his team that performance was critical and the rest of the company. And so in 2 days, they added an expires header and removed e-tags, and they were using Akamai, and their Akamai traffic dropped by 1/3. How many people here use Akamai? Not that many, wow. Again, imagine cutting your bill by 1/3, right? It's huge, and this is a very, it's more complex than turning on compression, but it's still a fairly simple change. And then Google, earlier we announced latency was part of AdWords Quality Score. About 2 years ago, we announced it was part of SEO, it was part of PageRank. And we go on to qualify that it's one of 200 signals, and et cetera, et cetera, et cetera. So it's not the hugest thing in the world, but it is a factor, and certainly people care about SEO. So you want to make your website fast. And so I saw all these things kind of converging about 2 years ago, and I'd been kind of tracking these things in the background and waiting for this serendipitous moment, and said, okay, it's time to announce this new industry. So I call it WPO. I'm really good at names. This is not a very good name, but I thought about it over the weekend, and it's the best I could come up with that had a website available and stuff like that. So it stands for Web Performance Optimization, and it's been fairly well adopted. There's now about 20 or 30 companies in this space, and they pretty much label themselves WPO companies, or sometimes FEO, Front-End Optimization. And the elevator pitch is it drives traffic to your site. We saw this with, it affects PageRank, it affects your AdWords quality score. We all know it improves the user experience, but we don't have to take that, we don't have to just trust our gut on that. There are all these studies from Bing and Google Search that show even though the websites are faster, people spend more time on the site, they do more page views per session, more sessions per month. So they do that because the user experience is better, they love it more. And we saw, again, many studies that talk about increasing revenue, and the icing on the cake is it reduces your operating costs. How many people want these things? Oh, yeah. Okay. It's hot. Is it hot? It's hot. Anything we can do that? Oh, I can talk louder, yeah. So that's WPO. Okay, so that's the first part. How do we feel about making websites fast? Are we all on the bus? Yeah. Let me hear you say yeah. Yeah. Yes. Come on, louder. Yes. Okay, on 3. 1, 2, 3. Yes! Okay, we want to make websites faster. It is so frustrating. Come on. Okay, part 2. So I've been throwing around this, web performance optimization, kind of loosey-goosey. Let me get a little more precise there. So actually, most of my career working on the web up until 2002, 2003 was on the back end. And then Ash and Jeff Ralston came and asked me to start this performance group at Yahoo. And I said, oh, cool, because I know a lot about back-end optimization, always like optimizing Apache and compilers and stuff like that. And Jeff said, no. And it's kind of a funny story, but I'm on video, but I won't tell it. I'll tell it after. I want you to do it from the end user's perspective. And I'm embarrassed to admit, by this time I had run my Yahoo team for 2 or 3 years. I had never looked at how a browser loads a web page. I had always looked at it from Apache's perspective. And if we could cut Apache's time from 200 milliseconds to 180 milliseconds on average, that was pretty good. And it would take months of work to make that happen. So I'm kind of talking about a different kind of performance here, and this is the way I try to break it down, is certainly back in the Web 1.0 days, this holds very true. Today, some of these other requests can be dynamic, but certainly in the Web 1.0 days, okay, so first of all, this is a waterfall chart. How many people have looked at a waterfall chart in the last week? Okay, so it's good you're here. The other people. Well, it's good. The people who raised your hand, I'm glad you're here too. Okay, so the other people, I'm really glad you're here. Okay, so this is a waterfall chart. Each horizontal bar is an HTTP request. It's a resource, right? And I forget where I got this. I think I got it from webpagetest.org. We'll look at that later. And you can see the time that it takes, and the different colors are different things, like DNS lookup, TCP, I forget what that is, TCP connection, and data download. And certainly in the Web 1.0 world, all of these things were static stuff, mostly images. And, we started adding CSS and JavaScript. But all of the back-end computation time where you're optimizing databases and optimizing RPCs and trying to make RPCs asynchronous and optimizing the compiler and doing DLLs and things like that, all of that was in this part, the back-end part, right? And all of this part I call front-end part. Now, a lot of people like to break it into three categories: back-end, network, and front-end. And by front-end, certainly we think of things like parsing and executing JavaScript, applying styles, parsing the HTML and laying out the DOM. All of that stuff's expensive. But there's also a lot of network time going in here. But the reason I just lump network in the front end is the browser is going to do pretty much what you tell it to do. And it turns out that there are a ton of ways that you can tell the browser to manage the network more efficiently without changing the network conditions at all. And this was true for the very first engagement I did back in 2004. The team said, well, what do you want to, back then we had this deal with SBC and people were still using a lot of dial-ups. Well, what do you want us to do? Give everyone a free DSL account? We can't do that. They have slow network connections. There's nothing we can do. And within a month, we had made the page twice as fast, right? And the network conditions hadn't changed. Just the way that we told the browser how to use the network had changed, and by doing that, we could make things much more efficient. So there are some things you can't do about network. There's some, it definitely is a factor, but I lump it into this front-end part because the people creating the page and that set of commands, the HTML that's commanding the browser what to do, those people can cause that network to be very inefficient, used very inefficiently or very efficiently. And so I want these people to feel some responsibility for that and take that into consideration when they're building and deploying their pages. And so I looked at this, and I forget what this is. It might be Google search now, but 8 years ago it was my Yahoo. And I was like, wow, all the time that, it's like that story about the drunk looking for his keys under the street light, but really lost them somewhere else, but the street light. Like, all that time I'd been trying to make my Yahoo faster. I'd been looking at Apache because that's what I knew. And that's how the web grew. It grew from people who knew servers and back ends and not so much of this stuff. We added this stuff, the HTML and stuff later. So this is where we focused, and still where most companies focus their performance efforts is on this back end part. And I'm not saying you shouldn't do that. Half of velocity is on this part. But you should focus on this part if you're worried about availability and failover and downtime, right? If what you want to do is make the user experience faster, create a faster experience for the users, you got to focus on this part, the front end part. So when I saw this, I was like, wow. I've been looking at for years, I've been looking at the wrong part. I've been optimizing the small pole in the tent, the short pole in the tent. Well, maybe it's an anomaly. So I started looking at other Yahoo sites. They all had the same profile. I looked at the Alexa Top 10, the Alexa Top 100. Every site that I've looked at for the last 8 years pretty much holds true for this. There are some exceptions, but by and large, this is true. This is what you'll see for almost all sites. So just recently, I went back. I think these are, I forget how long ago it was, about 6 months ago. But I bet I could go and look again and they'd be the same. So if we look at the Alexa Top 10, they have about 27% of the time that the user's waiting for the page to load is on the back end. But these sites are highly, highly optimized. They have very few requests, and so the pie is very small, and the HTML document, this is basically how much is the HTML document of the page load time out of the whole page load time. And for them, 27% on average is the HTML document. They typically, this is like the Google front page, the Yahoo search front page. Very few requests. The pie is very small, so the HTML document is a bigger slice of the pie. If we step up to the Alexa Top 1000, 17% is spent on the back end, and the Top 100,000, 16%. And so this was really the first kind of performance work discovery thing that I published, is the performance golden rule, where from looking at all these sites, I say 80 to 90% of the time that the user is waiting for the page to load is on this front-end part, front-end and networking part. So if you want to make the site faster, that's where you got to focus. And to drive it home, I tell most people, I might look at their site just to make sure they don't have they're not running on WordPress and MySQL's really slow or something like that. But almost always I see this profile, this 80-20 rule, and I say, you could, and they keep wanting to go back to optimize the backend. Well, maybe, if we run on AWS or Rackspace instead of AWS, or we buy our own servers, and I'm like, you know what, I'm just telling you, you could reduce the backend time to 0, and most people wouldn't notice, right? Because you're going from, the average site loads in about 8 seconds, so if you could cut 10% of that, it would be 7.2 seconds. People aren't going to care. But if you can cut the front-end time in half, which we've done successfully over and over and over again, you can make an 8-second site 4 seconds, right? So this is where you really need to focus if you want to make the website fast. If you look, there's a priori greater probability that you're going to have an impact if you work on this long poll than on this short poll, right? The changes are simpler. We're not re-architecting. We're not sharding across multiple data centers. We're adding an expires header. We're turning on gzip, right? Most of the changes are far simpler than a back-end optimization. And they've been proven to work over the last 8 years. I've worked with a ton of sites. There's all these other companies. And by deploying these best practices, we can make sites. It's pretty easy to make sites twice as fast. So I want to talk a little bit about, so I define kind of when I throw the word performance around, really what I mean is front-end performance, not scalability. I really mean how fast it is from the user's perspective. Then I want to talk about fast, like I say, how fast it is. What do you mean fast? Okay, so let's talk a little bit about metrics. So suppose I do a search for Steve Souders, and I get back search results, and I click on the one for my website, right? So this is the first, I'm going to highlight here 4 or 5 time measurements that we should all be familiar with and probably we should be tracking. Oh, and I didn't mention that before. So I think just like Union Square, if first round capital doesn't have it already, I think what Fred is doing there with having a dashboard for all the portfolio companies that is using standard metrics, I encourage every VC to do that. I think that's really, really valuable. And I noticed a lot of the companies here, or the ones who submitted URLs, are doing that with New Relic or some other metrics. And we'll give some examples in just a few slides. So these are all conceptual names of timing metrics, fast metrics, that would be good to be aware of. So there's time to first byte. So I've clicked on the search result, and it's gone to stevesouders.com. And that's the backend has stitched together an HTML document, and the first packet of that HTML document is back. And it's not until that first packet comes back that the browser clears the screen, right? So if the user clicks on a search result and your backend is really, really slow, they're going to be staring at Google search, and they're going to be like, well, how come, what's going on? And they'll click on it again, which will just reset that timer. They'll click on it, and finally they'll click on the next result. So time to first byte, it's important to keep that pretty short, right? And that will clear the browser, right? But until it gets enough to parse, it's not going to display anything. And if there's anything blocking, we'll talk about that. Anything that's blocking parsing, this is what the user is going to be staring at. And there's people in here, at least for the tests I ran, where people are staring at this for more than 10 seconds. And I'll point out those companies toward the end. And there's no, did you lock the door? No leaving early, no leaving early. Okay, then there's the start render point. Okay, there's nothing blocking the page, or at least we got it out of the way, and I got enough of the HTML document parsed that I can start drawing something. And this is really important. This is what Jacob Nielsen would talk about giving the user feedback, progress bar and stuff like that. Well, the page itself is a progress bar, right? If it stays blank, the user is not getting any update. So this is giving the user updates. So it's really important to know when did it go blank and when did I start showing the user that the server is actually not an idiot, that it's doing something and it's working, and eventually I'll get the page to you, okay? Then we have above the fold. So this is where basically almost all the content that the user is expecting or cares about or wants is going to appear. And the definition of fold depends. We can come up with kind of an industry standard. But you get the idea of what I mean is most of the stuff up here is showing. And then there's finally what we probably are all actually measuring. This is the thing that is kind of the de facto performance. How fast is it thing to measure is the window.onload time, the page load time. And that's going to include everything, including stuff below the fold, right? All the stuff that you load, all the images. The window.onload is not going to fire, which means the logo is going to continue to spin, the status bar is going to continue to flash until all of the images, all the scripts, all the style sheets in the page have been downloaded and parsed by the browser. So those are 4 metrics that would be really good to keep in mind, and we'll talk about those some more as we go on. And then this is kind of fun. So it used to be 3 or 4 years ago that window.onload was all people cared about. And not just me, but one drum I've been beating for the last 3 or 4 years is progressive rendering, progressive enhancement. So it is important to reduce your window.onload, but really we as an industry have adopted window.onload because it's the best proxy. What we really want to optimize is the user's perception, but there's no JavaScript event for the user's perception. So window.onload in the Web 1.0 world was the best proxy we had for the user's perception, but with Web 2.0 it's not, right? Because we can have stuff below the fold that takes a really long time to load. We're sending beacons and stuff like that that don't really affect the user experience, and the page is actually rendered above the fold. And so really what we want to do is focus more on rendering. The problem is it's really hard to measure that. But we can just, as humans, we can parse that pretty easily. So for example, suppose these are both my website. You guys recognize it because you go there every day. And just if you had to vote A or B, it starts off, it's blank. Finally, we get something to render. This one, it renders about halfway at 6 seconds, and then at 8 seconds, it's fully rendered above the fold. This one, it has the same amount of progressive rendering, and then at 6 seconds, it's done. Which do you think is better, A or B? What do you think, A or B? Yeah. You don't want to answer? Oh, you? Okay, yeah, you can answer. B. It's pretty obvious, right? These two are the same, and this is better than that, so B is better. If I could have my website do one or the other, which would I pick? I'd pick B. Okay. How about this one? Blank, a little bit of rendering, fully rendered. Blank, blank, fully rendered. Which would be better? What do you think? Yeah, because you're giving the user some feedback. This user, after 3 or 4 seconds, is going to say, let me go back to search results and see what the next one is, right? Okay, so that was pretty easy. They get a little harder. Blank, blank. Blank, progressive. Progressive, done, done. This one's a little harder. What? A? Because you gave the user feedback sooner? I would actually take B here. But it's close. But now,
4 seconds, 6 seconds.
yeah. Now here is the hardest one and the last one. This one's fully rendered at 6, but it didn't have much feedback. This one had more feedback and is fully rendered at 6.2. Which of those is better? I would take A. And this is what I mean by tail wagging the dog, is sometimes we get focused on the numbers, especially as engineers. And so we're going to look at this chart of window.onload, and we're mostly looking at that because there's nothing built in the browser right now that gives us feedback about rendering. And I've seen this many times where we deploy performance optimization best practices, and it makes the onload time slower. But it makes the user experience better. And so people are like, yeah, but we're tracking window.onload. A lot of IT people, maybe more on the East Coast, actually get their bonuses set by the window.onload calculated by Keynote or Gomez. And so like, if you're going to make the onload slower, there's a lot of resistance to that. And here I'll say, we didn't make the user experience that much better, but a lot of times you can make it significantly better. Like lazy loading images, right? Let's make sure everything above the fold renders first, and then we'll start downloading all the other stuff below the fold. And by inserting that delay, you might actually kick off those below the fold images later than you would have otherwise, which will make the onload fire later. But you've guaranteed the stuff the user can see is going to appear sooner. And that's a better user experience. So you got to be a little careful about what you're focusing on. It's a little tricky. So this kind of ties into that. How many people know about RUM data? A few people. So how can you gather this timing data? Well, you can do it synthetically. This is where we basically mean we're not using real users. Like we're asking QA people to do it with a stopwatch or a wristwatch. We're running in a lab. We're using some automated service, Keynote, web page tests, which I'll show in a minute. Water, Selenium. We're building scripts in a lab. But it's not real users. We've got a canned list of URLs that we're running through. Now, one of the benefits of this is because it's running in this synthetic environment that we control, the variables are very well understood. I'll give a great example is, well, here, let me talk about, so there's fewer variables. So because there's fewer variables, if you see a regression, you can diagnose the cause of that much more quickly. It's easier to isolate causes. And you can also gather more metrics, like there's nothing available in JavaScript that tells you the machine's CPU. But if you're doing this in the lab, you can gather CPU stats pretty easily. And that's something that we care about. So, and memory, and when did things render? There's no way to do render capturing out in the real world, but you can do it if you're running in a lab. Whereas RUM, real user monitoring, is with real users. And typically we do this with JavaScript in the page, and we look at these events like window.onload. We can put a script tag at the very top inside the head tag, and that will basically tell us the time to first byte. So that's what's done. Real user, you deploy it on your live website running out in the world. Again, I saw a lot of people doing that with New Relic. You can do it with Google Analytics. I should add New Relic here. Boomerang is from Yahoo. Torbit is a new company that offers RUM service. And the pro about this is, here I had to come up with a list of URLs to track, and I always go back. I know Brian from Yahoo Sports. I always have this sports analogy where the Tour de France is going on, but when you set up your lab, you picked sports.yahoo.com/NFL/MLB/NBA. Those are the most popular pages. Well, right now, this week, when the Tour de France is going on, /cycling is the most popular page, and you don't have any monitoring on that, right? Because you don't change your lab setup depending on what time of year it is. And so this reflects what users are really doing. It reflects what browser they have, what their hardware is like. Is it slow? Is it fast? Are they upgrading hardware? I don't know, but if I measure it on real users, it's my real users, so it's the hardware my users actually use. What's their network conditions? What's their page flow? Are they going to cycling or MLB? Where are they geographically located, et cetera? I'll give a great example of this is there's a very popular website that had a regression in their RUM data, but it was not reflected here, right? And it turned out they had run an ad campaign in a European country that had gone up 10x in the number of people using that website, and there was no data center near there. So all of those 10x amount of people were contributing really slow RUM times. And so that was a time that we really cared about having both of these in place. We could go here and we could go, well, we don't think it's a regression with the code. Because when we control the variables, so what's going on outside of the variables? And that way we were able to lead us to things that said, well, let's break it down by country. Wow, in this country, we've got a 10x increase. What happened? And then one of the engineers connected with someone in marketing who said, oh yeah, we just did that marketing campaign there. Vice versa is like the cycling example, or which browser are you running on? You're probably not going to run on 3 or certainly 5 or 10 browsers in the lab, but your users might be swinging from IE to Chrome or something like that, and so you want to make sure to capture that. So both are important. I think this one is a little easier and lower cost. I always like to start looking at this data and then only fall back to this data if I can't figure out what's going on here or I see like unexplained regressions. When I see a regression that happens, when I see RUM data get slow on the day we do a push, I know it's the push, right? Okay. Oh, and here's just some screenshots. How many people here use Google Analytics? So how many people here know Google Analytics is recording how fast your website is? Oh, that's very cool. Yeah, so we added that by default about a year ago, and we told people, and it's available inside. I think this is the old UI actually, but you can go into Google Analytics now. Even if you've never set it up, we're gathering RUM data as part of Google Analytics running in your website. We do a very small sample size, but you can do some JavaScript and increase the sample size. So even if you haven't been doing anything, there's probably a year's worth of RUM data for you. And here's Philip Tellis from Yahoo started this company called LogNormal that just got acquired by Sosta. They're a load testing company. And they offer RUM data and some nice plots, and Torbit is this other startup down in San Mateo or something like that. Okay, so that's what I mean by performance and how to measure speed. So this is the last part, some of the best practices. So I'm just going to really quick, and I forgot to tell people to stop and ask questions, stop me and ask questions. Because, so I don't know about you, so far I'd probably be really bored. There's just this one guy talking on and on and on. Yeah?
Have you told any jokes?
Well, there was the one about slow things fast and focus on the background things.
Oh, yeah, that's right.
Yeah.
I forgot.
But from this point forward, when I do them, I'll highlight them afterward.
Cool.
So we can track those better. Any other questions? Okay, so about 20 minutes. Okay, we're going to rifle through these. So it turned out both books had a very simple thing. How many people remember Scott Meyer's Effective C++? Yeah, I loved that book. And so I kind of modeled my book after that. I wanted a book where you could read one chapter by itself, and it really didn't depend on anything. You could read it if you had 50, and the book is small, so you could read it like if you're on the bus for 15 or 20 minutes. So just 14 standalone best practices, and it's much more Web 1.0 sort of stuff, gzip and expires header, HTTP stuff, avoiding redirects. And it turned out the second book had 14 rules too. But a lot of what I focused on were these weird idiosyncrasies about how browsers work. And it was really fun because I would like black box play with a browser and go, wow, I wonder why it does. I would just notice things as I'm using websites. Wow, why did that take so long? And I'd open up a packet sniffer. Huh, I wonder why those scripts are all downloading sequentially. Oh, wow, look at that. That's the way all browsers download scripts. They download them sequentially, at least in IE. How about the other browsers? Yep, Firefox, yep, Opera, yep. Back then, Chrome wasn't around. And one of the ways I did that was with this tool, Cuzillion. How many people here have played with Cuzillion? Okay, so I'm going to try to do this, and I think it will work. First, I'm going to escape out of PowerPoint, and then I'm going to go to Chrome, and I'm going to go to Cuzillion.com, which actually is a redirect. And so I built this because, I actually built this for the second book because there were so many weird scenarios I wanted to test, and I was building like a custom test page for each scenario. I started writing the second book, and I realized I had like 390 test scenarios, and I didn't want to build that many pages, so I just created this. So one that's really interesting is let's add an external style sheet. Let's make it take 5 seconds to download. And then let's add an image. And by default, everything takes 2 seconds to download. Let's just say there's no delay. This is a delay on the server. And so now I can actually request this page. So let's count. The image is going to show up at the top. It'll be like a little turtle or crab or something like that. Let's see how long it takes for that to show up. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. So if the crab doesn't take any time to download, how come it took 5 seconds? Well, guess what? If we change the style sheet to take 7 seconds, it's going to take 7 seconds. If we change the style sheet to take 3 seconds, it's going to take 3 seconds. And that's because style sheets block all rendering in the page, right? Let's see, what are some other, well, I don't have IE here, but so we can do this. We can, by creating these examples really quickly and easily, we can kind of look at the nuances of how browsers work. And the other thing that's really cool is you can just, you can copy and paste these URLs in any browser or send them to, submit them in bugs to browser developers, and people can recreate the test page over and over and over again consistently. So this is a really fun thing. If you're ever wondering, like, what's the interaction? Like, oh, so here's another good one. Okay, let's clear, and let's add 1, 2, 3, 4, 5, 6, 7. 7 images that each take 2 seconds to download. What do you think the window.onload time for this page is going to be? Yeah, 4 seconds. Why? Download 6 things at once. So here, let's create the page. And we see 6 show up, and then the 7th one. And if we look down here, I show the onload time is 4 seconds. Now, if we delete one of those and create that page, it's 2 seconds. So that's how it's really easy to see. And it turns out most major browsers do 6 connections per host name, but there are some out there that do 8 and some that do 4. And with this, you can really easily create a test case to see how browsers work. So Cuzillion, kind of fun. So I think I'm pretty good at names because there are a zillion pages to check. Cuzillion. Yeah. Okay, so here's the first rule from the book. So I'm just going to touch on a couple of these things. Make fewer HTTP requests. It turns out it's still the #1 rule in the second book and for anything that you do. This is an actual chart of the size of pages over the last 2 years from the HTTP archive. So things are just getting bigger and bigger. The average website in November was 87 HTTP requests, 1.3 meg. Each HTTP request has overhead, even if you're reusing connections. Cookies have to be sent every time. If you're starting new connections, then you might have slow start. And so, one way to make sites faster is just to tell the designers to take stuff off the page, and that never goes over really well. So the challenge I set for myself 8 years ago was, can we make it faster with the stuff that's already on the page? And it turns out you can. You can do things like, okay, so anyone know what this is? Whoa. I spent a lot of time in Nebraska growing up, so I didn't think other people would get that. Okay, so that was a joke.
Endless.
That was
Endless in Nebraska.
Yeah. Okay.
Good job.
So I don't mean combine scripts with style sheets. Everyone probably knows this now. I just mean concatenate your script. Typically, we used to have 10 to 20 to 30 scripts on a page, and it's just put those scripts together because scripts block things in the page, and if you put them together, they're going to get done faster. Scripts are the most painful when it comes to performance thing to download byte for byte than anything else on the page. So you want to get those out of the way. If you have multiple style sheets are the next most painful byte for byte thing to download. Concatenate those into one to get them downloaded more. And you can take these to extremes. Like if you have 600K of CSS, well, you might want to break it into 2 that can download in parallel. But for most people, it's good to just put it into 1. And you can do that. There's modules to do that. There's a combo handler blog post you can read and recreate that yourself. You can use data URLs. I saw several websites doing that in the list that I got. That just means that anything that actually could generate an HTTP request, you can actually, just embed that HTTP response in the page itself. And you do that by encoding it as Base64. And so, anywhere where you can put a URL, you can put a data : response body. And you say what it is in Base64. And mostly this is good for small things, not just images, but also scripts and style sheets. Why small? Because Base64 encoding it actually makes it bigger, and it's also kind of a pain in the neck to deal with. Also, it's in the page itself, so very rarely do we say cache my HTML response. But if it's like 100K of JavaScript, you put that in a separate script and you say cache the script by itself. But for small things, it's probably better to put it in the page than generate a new HTTP request. There is a little bit of a workaround. Like if it's background images, rather than embed it in the page, you could embed it in a style sheet and keep that cached forever. So that would be a way to reduce images. Images are about 60% of all the bytes downloaded on pages these days. Yeah?
For small images, is that preferred over spriting a bunch of them together?
Well, I think that's kind of a personal preference thing. I'll talk about spriting next. To me, spriting is kind of an even bigger pain in the neck. Like you could automate something like this in your build process or in your server. It's really, I've met very few people who automate the creation of sprites. And the CSS, the connection between the CSS and sprites is really complicated. So I would prefer this technique. If there were things that I could sprite that I used like for a long period of time, I would do that. But I wouldn't want to do anything as a sprite that I have to change like on a monthly or weekly basis. Speaking of sprites, yeah, so now I broke something before, but I'm going to go for it again. Here's where we're going to look at ModCloth. Where was ModCloth? Okay, so I looked at some of the websites out there, and some people are already using sprites. This was one that isn't super compelling, but I think there's a good, compelling reason to use sprites on the site. So I wrote this bookmarklet called SpriteMe. You can go to spriteme.org and get it. And so it's a bookmarklet. I just click on it. And it loads every image, every CSS background image in the page. And you can just go over these and hover over them and see, all the background images in the page. And, so look, you guys are using sprites. Cool, right? And it turns out it's really complicated. There's a lot of arcane knowledge in what images you can combine together. Like, are they repeat X, repeat Y, both? Are they in an element that's much bigger than the sprites, in which case you have to put a lot of padding around it if you want to sprite it. And so this basically, SpriteMe just looks at all the images and applies that arcane knowledge and suggests what you should sprite. So it said, well, I think you could sprite all of these together. And you just click on Make Sprite. And it actually goes off to this guy, Jared Hirsch's website. I teamed up with him. And it takes all those images and combines them all and returns the sprite image to me. And then I actually changed all the CSS in the page that you're looking at right now to use this sprite image. So here's the sprite. You could actually download it and save it. And you can say export CSS. And it doesn't like generate your new style sheets, but it says, well, you'll have to change this rule to say background, blah, 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 blah. So it gives you some tips. Now, in this case, we reduced 7 requests, but we increased by 21K. So typically, that's probably actually a good trade-off. But it might be more than I would want to do. And usually, there's like one image that is kind of increasing the color map or something like that. And I think I looked at this and concluded it was probably this one. So, oh yeah, he does performance and drag and drop. And I think I wrote that myself, too. So now we can try this one. And I think we'll get, so instead of saving 7 requests, we'll save 6. But I think we get a smaller increase. Did I click on it?
God, I wish this were faster.
Well, it's the image generation stuff. That's Jared.
That was a joke, right?
So yeah, so it's only 13K more and save 6 requests. So that's pretty good. So I don't know if it actually makes sense for you to do that. But anyway, it's a nice tool to play with. And actually, it's all open source. So people have taken this and they have actually used the code and the logic to put into automatic sprite generators. So that's another way that you can reduce the improve performance without reducing the actual content on the page. Yeah, so there's the example. So I'm not going to talk about any of others of these unless there's questions about them.
What's number 7?
Number 7, avoid CSS expressions. Well, so I wrote this book in 2007 when IE was still pretty big. And IE supported something called CSS Expressions where you could actually embed JavaScript code inside of a CSS rule. Well, it turned out that like you could put something, you could have like something that would do something to a style on a hover. And then when you move the mouse over the page, that JavaScript would execute about 50,000 times.
Oh,
Right? And so people would see this where they were using CSS expressions and other browsers just ignore it. But in IE, their pages would just freeze. And so, it's don't use them, or if you have to use them, there are ways that you can actually add them, but then have them be, reflexive and remove themselves when they're not needed and make themselves faster. Yeah?
Are there any secrets to reducing DNS lookups aside from using your DNS?
No, there's not really any secrets. The main one is if you look at your site, I think web page tests will tell you, like, people sometimes create gratuitous subdomains. And, if you look at your page and you have like 2 subdomains that only have 1 request each, like, could you maybe move those over to a domain that you're already using? And we actually do that a lot at Google. I would find cases where we had something on something else that's like, yeah, can you just maybe serve it from this other one? Well, we want to keep that separate and track the logs. I go, a new DNS lookup? Really? Do we need that? I don't think there are any other like silver bullet secrets there. Yeah.
But on the other hand, don't you sometimes want to split your, for example, images so that you can download more at a time?
Yeah, so that's a good segue, because, to the second book. And on this one, I had a lot of great contributors, but one of the ones I wrote was domain sharding. Sharding dominant domains. So, exactly what you were saying is, and we'll have some examples of this from the URLs that were submitted. If, so that, as we discovered before, a browser will only download 6 requests in parallel for a given host name. It's not IP address, it's host name based. So you can create, 4 CNAMEs to the same web server, www1 dot, www2, www3, www4 dot. And if you have 24 images, put the first 6 on domain 1, second 6, third 6, and all 24 will download in parallel, right? Now, maybe that's a good thing, maybe that's a bad thing. And it turns out most studies, that I did and that other people have done say it's best not to shard across more than 2 domains, but it depends on how many resources you have. Certainly, I think if you have more than 20 resources on one domain and you have a typical page with 50 to 100 resources, it's probably a good idea to shard those across 2 domains. So in that case, now the downside of doing that is there's two main downsides. You have an extra DNS lookup, and then you're using more connection. And if we know about the congestion window, it gradually gets bigger as the browser has more experience with this connection. It will allow data, larger amounts of data to come down. And so if you keep reusing the same connection, it gets smarter and smarter and smarter and more efficient, assuming you don't have a lot of packet loss. But if you use more connections, that learning curve has to be endured by every connection. It's not like this connection to www.foobar.com has a huge congestion window that it learns, so let's give that congestion window to all the other connections. TCP doesn't work that way. So those are the two main downsides. Okay, so this book was much more targeted at Web 2.0 stuff. And so when I'm out at bowling parties and stuff like that, typically people, I actually don't have any social life. All I do is talk about performance all the time. And so I stand around and people eventually come up and ask me something about performance, like, what's the main thing I can do to make my website slower? Like I would love to, or actually it goes more like this. I would love it if I could get some of your time to look at our website and tell us what we can do to make it faster. And I always say the same thing. Oh, I don't have to look at your website. I can tell you right now, the thing that's making your website slow is JavaScript. And they go, how do you know that? I go, do you use JavaScript on your website? Yes, that's how I know. Right? And so this is what I alluded to before, is JavaScript byte for byte is the most painful thing to download. So this is how, so why is that? It's because scripts block. So this is the old world, right? This is the old world. It turned out, and with Cuzillion I was able to figure this out, that, so here's an HTML document, script, image, style sheet, iframe. It turns out, in the old days, when the browser hit a script tag for an external script, it would stop doing everything else. It would stop parsing the HTML document. It would stop all other downloads until it had downloaded this script and parsed and executed it. I didn't show you in Cuzillion, but for scripts you can say, how long should I take to download and how long should I take to, for the script to have execution time? I just go into a while loop. And so here, for each of these scripts, I said 2 seconds to download, 2 seconds to execute, and then these style sheet, image, and iframe were each 1 second. And so in these browsers, this is what the waterfall chart looks like. Document, the first script, stop everything else. Parse, download, parse, and execute. Second script, stop everything else. Download, parse, and execute, and then download these other things. And guess what? It's not just that it blocks other downloads, it blocks rendering. And this is still something that's true today. The browser will not render any DOM element that's below a script tag until that script tag, whether it's inline or external, has been downloaded, in the case of external, and parsed and executed. Well, guess what? Most people put their script tags in the head, which means everything in the DOM element below that, like the body, will be blocked from rendering. So your entire page is blocked from rendering until this has happened, right? That's why it's so painful. And this really doesn't make sense, right? So why did browsers do this? It's because browsers are built by humans that have lives outside of work, wives and kids and social bowling events.
Oh, that was?
Yeah. And so they said, well, you know, if we just download and execute JavaScript willy-nilly, we're going to get these race conditions. We're going to get undefined symbol errors if this script depends on this script, but it gets parsed first. So we want to very, very rigidly enforce JavaScript will be executed in the order that it's declared in the page. Okay, I totally get that. But why don't you download them both in parallel? I mean, while this guy was taking 2 seconds to download, you could have downloaded this one, and maybe this one only took 100 milliseconds. Well, just don't parse and execute it, right? Just take the bytes and save them, and then when this one is finally done, parse and execute this one. And so, like, I actually told the browsers that, and they did it. I think it's the most important performance change, all the V8 and JVM stuff. I think this is the most important change that browsers have made in the last 5 years. So now on all the new browsers, they will download scripts in parallel with each other and with other stuff. IE 8 and 9, this was 6 to 7. IE 8 and 9 actually will download scripts in parallel with each other, but will still block everything else. IE 10 finally fixed that. And they take care of the issue of ensuring that even though these two got done at the same time, even if this one got done a little earlier, it's not going to parse and execute it until this one is done. So what we see here is we see 2 seconds to download This one only took a second. It's the style sheet. 2 seconds to download, 2 seconds to parse and execute the first one, 2 seconds to parse and execute the second one, and then we download the rest. And it's not until this point right here that we can do rendering. So rendering is still blocked, but we're going to get to that point. These aren't at the same scale, or actually maybe they are. So we actually start rendering at 6 seconds instead of 8 seconds, right? So, and the total download time is 7 seconds. But we can see this still isn't perfect. Why didn't these get downloaded in parallel as well? And again, this is actually kind of, I should look and update this chart. It's just built by humans, right? And so like one of the browsers, so what they do is they all added this thing called look-ahead parsing, speculative parsing, where they stop parsing and rendering DOM elements once they hit this script tag, but they'll do look-ahead parsing where they just look a little bit ahead and they see if there's any other things like the script, IMG, link tag, and if so, it will say, oh, well, let's download these things in parallel, and we have to deal with them maybe a little carefully until this one is done, but let's get the download pain out of the way. And they forgot to add iframe. And so I submitted a bug, and they were like, oh, yeah, we forgot to add iframe to that list of tags to look for. Or they only look ahead a certain number of bytes. Or maybe it's your fault. Maybe it took a long time in the HTML document. You got these bytes down pretty fast, and these took a long time, and before these bytes came down in the HTML document, it had already started, and it wasn't going to kick off any new downloads at that point. But anyway, we're a lot better off than we were before, but it's still not as optimal as we would like, especially IE 8 and 9. Not downloading images in parallel with scripts seems like a huge miss. But JavaScript is still a big pain. If we look at the Alexa Top 100, I did this little study where I disabled JavaScript. And if I disable JavaScript, it cuts 31% off the window.onload time. And it's hard to think of something that would be a bigger factor than that. So JavaScript is still byte for byte the biggest pain, and it's growing, right, over time. So we got to figure out a way to get our arms around this problem. One of the rules in the second book was to split the initial payload. So here we look at some top sites, how much JavaScript they have, and what percentage of the functions in this JavaScript are actually executed before the onload event. And it turns out on average it's less than 30%. So why are they downloading JavaScript that's not executed? Well, it could be like error handling, and we just didn't trip on the error. But it's probably mostly DHTML things, like if you click on the Compose button or address book, it's going to pop up a div and let you type stuff or show you a list of things or stuff like that. I love DHTML, but if really it's not part of rendering the initial page, separate that code out and lazy load it. Like after the initial page is rendered, maybe in the window onload event, download the rest of that JavaScript. And you're going to have to be a little careful, like you wouldn't attach the onload handler to a Compose button until that lazy loaded JavaScript was done. The lazy loaded JavaScript would do it itself. So split the initial payload between what's needed to render the page and everything else, defer everything else. Page speed, that's actually one word now. I've got to update my slide. Major branding change. It's going to make a big difference.
White space matters.
Yeah. My slides will be so much faster. And there's a tool from Delato that will do it automatically for you, but it's not perfect. But you're still going to have scripts that you're going to load as part of the page, and so you want to do that without blocking the page. So back in 1995, we typically put our scripts at the top, browsers blocked. This would block everything in the body. They were downloaded sequentially. It blocks rendering. In 2007, in my book, first book, I said, move scripts to the bottom, right? And this is pretty good advice because it means it's not blocking, right? If this takes a long time, there's no DOM elements that are blocked from rendering. So it doesn't, and it doesn't block other downloads in the old browsers. There's nothing below this, so it can't block other images and scripts from downloading. But they still downloaded sequentially in IE 6 and 7. And even today, that would happen in those older browsers. And once this JavaScript arrives, suppose it's 300K of JavaScript, it's going to block the UI thread, right? And so if the UI thread was still rendering the page, rendering could potentially be blocked. So we can actually do better than that. So the second book talked about loading scripts asynchronously. And this is a pattern from my book that now has been popularized greatly by Google Analytics, where you create a script element, you set its source, and then you add it to the head, append child, or do insert before. And this won't block any other downloads, even if you put it at the top of the page. It won't block any other downloads across all browsers. It will download in parallel with everything else. Even in IE, it will download in parallel with images. But when the payload arrives, if it's 300K, it is going to block the UI thread, right? Because there's only one thread that the browser can use. So we can even get around that. How can we possibly get around that last red one? This is a hack from a couple years ago that Gmail Mobile talked about. So they had this challenge where you're running Gmail on here, and let's say there's 120K for the JavaScript for the compose div that pops up. And you don't need that to render the page, so we're going to lazy load it, right? Well, one thing you could do is you could wait till the user clicks on the compose button and then download 120K over the mobile network. Well, that's not a great idea, right? The user clicked on compose and they're waiting. Okay, well, let's do it in the background. How do we do that? Okay, in the window onload event, we'll download 120K of JavaScript. So the user hasn't clicked on compose, and they're trying to interact with the page, and it doesn't hear their click because it's parsing 120K of JavaScript, which might not be a lot on the desktop. On a small device, it can take a fair amount of time. So we're blocking the UI thread for this JavaScript that's being parsed and executed that the user may never want. So instead, what they do is they download the JavaScript and comment out the code. So it's not parsed and executed, but the bytes are on the device, right? The bytes have been downloaded in the background, but I have not blocked the UI thread to parse and execute. And so when the user clicks on the compose button, you get this script DOM element, get the .text property, remove the comments, and eval.
Oh my God.
Right? So eval is just as fast as if you had a normal script block, right? And eval is bad for security if it's JavaScript that you don't know what's in it, but you do this for your code, not for an advertiser's code. You do this for your code, and it's perfectly fine. So it's good for performance, it's safe for security, and it's a better user experience. When I click on compose, and there's a little bit of a delay, I'm not that surprised because I asked for something, and the delay is not that long because I'm not waiting for the download. I'm just waiting for the parse and execute. So that's, I think, a really, really great hack.
That's quite a hack.
Yeah. But it's kind of hard to do. So I wrote this JavaScript library called ControlJS. There are a lot of script loaders, and I just thought none of them were doing as good of a job as they could. So I actually wrote this as a proof of concept, but it turns out it's been, like Washington Post is using it. I'm pretty sure New Relic and a couple other of these web accelerator companies use it. And I took a different approach. As I said, let's do it in markup. So if you change the type, then the browser won't try to parse and execute it. And so you can do this. You can change your markup to say stuff like that. And it works for external scripts and inline scripts. No other loader that I know of does that. And so it makes sure, and yet this is a very typical pattern. We're going to download some JavaScript in a library, and then we're going to have some inline code that calls it. And no other asynchronous script loader supports that, as far as I know, last time I checked. The other thing that's really cool about ControlJS is you can load itself, the ControlJS library, asynchronously. So the whole thing will work asynchronously and not block the page. And then if you want to do that Gmail hack, you just say execute false, and it will download it and not execute it. And then later, you can just get hold of that element. Or no, you just have the URL and say execute script, and it will find this DOM element. And it doesn't do quite the hack that they did, but it's something similar. So this is a nice little library, more to look at as an example, but really to push the envelope. And now other people have started doing this, especially the people that have adopted the library. And then let's talk about mobile really quick. I'm running out of time. What time did I? Oh, wow, I'm way past. OK, you can do sprites, data URLs, but also mobile browsers are more up to date, so you can use CSS stuff, Canvas, SVG. You want to, images take 60% of the bytes on web pages, and you don't want to download your desktop images to a browser, so what do? Create multiple sizes of your images. That's a huge pain in the neck. So there's this whole responsive images problem that the picture and source set proposals are trying to solve. But there are some other solutions out there. I really like Sencha.io source. You just take your image and prefix it with this, and they will do user agent sniffing and resize the image for you automatically. And you can buy it from them if you want, or you could build something very similar. Or you could look at a client-side solution. I don't like these as much. Here it is. Because images are really the most important thing to download because they're visual. CSS and JavaScript aren't visual in and of themselves, but the images are. And they're usually one of the primary visual elements on the page. And so we really want to get images in front of the page as quickly as possible. But I say that they're less important byte for byte than JavaScript and style sheets, just because JavaScript and style sheets block images. So if we can get images down faster, that's really important. These client-side techniques actually delay how early you can get the images to download. So I don't like them very much. But I do like the background photo, like images, different sizes, just like Russian dolls. Or if we talk about offline app cache, why are we in a desert? Because often the reception in the middle of a desert is poor. You might need to work offline. I've got a much better jokes toward the end. Keep waiting. How many people use app cache? Yeah, it's kind of hard to work with. You specify the manifest attribute, specify your app cache file. It has to be formatted like this. Cache means you can save this in the cache. Network means never save in the cache. Fallback means if the user's online, use this one. If they're offline, use this one. Like you wouldn't want to show them a login form if they're offline. And it has to have a special, content type. But it's really hard to work with. If you specify the manifest attribute, the HTML document is also saved into the app cache, so it won't get updated every time. If anything in the manifest file 404s, then nothing is saved to app cache. You're limited to about 5 meg. If you change a script or image, you have to also modify, not just touch, but modify the manifest file. And if you do both of those, modify an image and a manifest file, the user still won't see that update until the second time they load the app. And I don't have time to go into that, but that threw me off for a day on my first app cache app. An alternative that's much simpler is local storage, get item, set item. And this was really meant as maybe alternative for local storage over cookies, but it still supports 5 meg, and people are using it as a cache. This was a study I did where both Google Search and Bing were doing the same thing. Rather than put for mobile, rather than put scripts and style sheets in their pages, in the first time you did a search, they would embed all of these script and style blocks. But then at the end, they would have JavaScript that would save those blocks to local storage. So this is actually a key in local storage. I think this is Google's implementation. And they would also set a cookie that would list all the modules that had been saved to local storage. So now you do another search, and the server says, oh, well, here's the search results, and I need to give you this module of JavaScript, but first let me look at your cookie. Oh, you already have that one, then I don't need to give it to you. And you need this module of CSS. Oh, it's already in your cookie, I don't need to give it to you. And this changes the size of the Google or Bing search results by about 90%. It goes from about 100K to 10K, because it can just read these out of local storage rather than downloading them. And they do this on mobile because mobile cache sizes are so small. Okay, so that took longer than I expected. So what are the takeaways? Speed matters. We're all on that bus, right? We don't want to do that yes thing again. Make sure to track metrics, and I give you some ideas of the metrics to track, and it's pretty easy to do RUM if you're using Google Analytics. If you want to make the user experience faster, you got to focus on this front-end stuff. There's lots of best practices out there. I've got a lot, but other people are doing similar things. And there are a lot of tools. I didn't go into the tools here, but if you download the deck, there's about 20 slides of tools that you can look at. And you can find the deck on my website right there. OK, thank you very much.